Lesson 14.12, determinant and inverse of a 2x2 matrix. So this is the last two things that you really need to know about a matrix. Is there's something that's called the determinant, and it ends up just being a number. And the way you want to find the determinant is pretty quick if it's a 2x2. You take A times D, so this diagonal, minus the B times C, the other diagonal. So if I want to find the determinant of this specific matrix, I'm going to take 6 times 5 and subtract 6 times 3. 6 times 5 is 30, minus 18. That would make the determinant be 12. So that's almost quicker than doing it on the calculator, but I will at some point show you how to do that too. Okay, then I want to move on to the inverse, which will still be finding the determinant as well. It says find the inverse of this matrix or state that there is no inverse. For one, I want to talk about what an inverse is. If I have multiplication, let's see if I have 3 times something, I want it to equal 1. Well, I would have to take 3 times its inverse, or really its reciprocal of 1/3. 1/3 times 3 would be 1. But remember, we can't divide, and so that's why we call it an inverse. It's just really, it's kind of reciprocal. Okay, so if we're wanting to find this inverse, first I want you to figure out the determinant. Let's do it by hand. So it would be -7 times 1 minus 8 times -1, which would be -7 minus -8, which would turn into +8. So that's actually just 1. Okay, then what I want you to do is go to matrix, edit matrix A, 2x2, and we're going to put in these elements, and then get out of that, and then go back to second matrix, select A first, and then right here, the button we've been pushing all along for the matrix has x to the -1st power. Hit that, and that will be our inverse of our matrix, and it's 1, -8, 1, -7. I want you to see the pattern from the original to here. See how the 1 and the -7 got flip-flopped? And then here, the -1 and 8 got flip-flopped, but now the 8 is, or they didn't get flip-flopped, sorry. The 8 became negative and the -1 became positive. So it reverses or flips the first diagonal, and then it negates the second diagonal. So it's kind of a cool pattern that can speed you up, and you don't even have to put it on a calculator. And so I put it here that the inverse, or we'll talk about more about this part, but it switches the D and the A, negates the B and the C. All right, let's try number 3. Let's find the determinant real quick. 6 times -7 minus 7 times -5. Be -42 plus 35, which is -7. Okay, go ahead and put this new inverse in and find the new matrix in, and find the inverse. And when I do that, I get some weird decimals. So go ahead and go math, enter, and it changes it into 1, 1, -5/7, and -6/7. And so let's look at the pattern here. It really flip-flopped the 6 and the -7, but what happens is it gets divided by -7 or times -1/7, which is here. And so it's -7 divided by -7 got 1. This 6 became a -6 divided by -7. Should have been... No, it didn't negate them. Sorry. That 6 got divided by -7 and became -6/7. And then these two just negated. So that's a -7 divided by -7 made 1. And then -5 became 5 divided by -7 is -5/7. So again, it can kind of speed you up if you know the pattern. And let's do one more. We're going to do 5 times -4. Woo. 2 times -10 minus -4 times 5. -20 minus -20 or plus 20 is 0. If your determinant is 0, think about we're having to divide these numbers by 0. Thinking of instead of 1 over this, even that we're dividing by the determinant of 0. That's not going to have an inverse. If you forget about it, you could still put your values in to your matrix. and try to find the inverse, and it's going to say error singular matrix, but that means it has a determinant of 0. So you would say there's no inverse.